Hello guys, today we will discuss special quadrilaterals and their properties. The first example will be about parallelogram. Parallelogram is a quadrilateral where we have two pairs of parallel sides. If we are given ABCD parallelogram, AB is parallel to CD and BC is parallel to AD. At first we will prove that opposite sides are congruent. We can easily notice that angle BAC and angle ACD will be same by parallelity rule, parallelity condition, and similarly BCA will be equivalent of CAD. And we will notice that triangle ABC is congruent to triangle CDA because of angle side angle equality, which clearly means that AB equals to CD and BC equals to DA. Next property about parallelogram is that diagonals bisect each other. If we have diagonal intersection point E, we will prove that BE equals ED and similarly AE equals EC. To show this, we will use once again parallelity condition. Angle ABE is equivalent of angle EDC. And we will have ECD triangle and EAB triangle congruent because of angle side angle property. ECD will be congruent to EAB, which clearly means that EC equals EA and ED equals EB. Next lemma about parallelogram is that all triangles made up by the diagonal intersections will have the equal area. So area of BEC equals area of ABE equals area of AED and equals area of ECD. It's clear that if this one is S1, AED will be also S1 because they are congruent triangles. And let's assume that these two triangles are S2 and S2. As we know that AE equals to EC, here we can use a well-known lemma that if in a triangle we have median bisects the area into two equal parts. This is S1 and this is S2, and M is the midpoint of segment AB. S1 equals to S2. And here as we have E midpoint of AC segment, clearly S1 equals to S2. And we have proved that all of these triangles will have the same area. Now, next lemma about parallelogram is that if we want to compute the area of ABCD, we can just use AB times AD times sine BAD. This looks like very much to the triangle formula, but here we don't have over 2 because these two triangles will have the same area. ABD triangle and BCD triangle areas are the same. Another formula for computing the area is product of diagonals. So AC times BD times sine of angle AEB divided by 2. Here we can just apply the area of AEB, which is AE times EB times sine AEB over 2. And if we multiply this area by 4, we will get the whole parallelogram area. So this is AE times AB times sine AEB. And multiplying this area 4 times will give us this formula. As we know, because we know that AE and EB are half of the diagonals. So this was all about parallelogram. Next special quadrilateral is rectangle. This is specific case of parallelogram where we have all of the angles 90 degrees. Difference between the parallelogram and rectangle properties is that here we have equal diagonals. Generally in parallelogram, AC and BD aren't the same, but in rectangle, if you use Pythagorean theorem, we can easily see that BD equals to AC. Also, we can easily see that BD and AC, both of them can be computed as square root x square plus y square, where x and y are side lengths of the parallelogram. In our case, rectangle. Very similar case to rectangle is about rhombus, and in rhombus difference is that here we have all of the sides equal. But in this case, diagonals are not necessarily the same. But diagonals will be perpendicular to each other. And to show this, we can easily see that triangle ABC, A call this point K, ABK is similar to CBK because of side angle side property. Like CB equals AB and BK is common. And clearly this means that ABC will be isosceles triangle, and as we have median here, median will be also altitude and angle bisector. So these angles are same, clearly here. And similarly, diagonals are also angle bisectors. This is one more additional property, which was not characteristic for parallelogram or for parallelogram and rectangle. I mean, common parallelograms. Also, if we want to compute the area of the like rhombus, we can just write BD times AC over 2. As we have 90 degree here and sine of 90 equals to 1. So this will be just BD times AC divided by 2. And the most well-known example of parallelogram is, of course, square. And in square, this is just composition of rectangle and rhombus. Because here we have all of the sides equivalent, all of the diagonals perpendicular, and right angles in everywhere. Clearly here, area can be computed as AB times CD or just AB square because all of the sides are same, and we have 90 degree here, or AC times BD divided by 2. So AC times BD divided by 2, this equals AB squared and equals area of ABCD. And so if this part is x, this is x, BD will be x root 2. And the final example for today's video is orthodiagonal quadrilaterals, which are less well known. And this is the case when diagonals are perpendicular to each other. If we just choose quadrilateral such that AC is perpendicular to BD, here we will get AB square plus CD square equals BC square plus AD squared. And to show this, we will just use Pythagorean theorems in AEB triangle, BC, CD, and AED. So AB square can be written as AE square plus BE squared. CD square can be written as EC square plus ED squared. BC square can be written as BE square plus C squared. And AD squared can be written as AE squared plus ED squared. This lemma is also oppositely correct. If we have this condition, this means that these diagonals will be perpendicular to each other. You can try to prove this reverse order at home, and if you have any questions, write in the comments. And always don't forget to like and subscribe my video.